In this particular video, let's discuss what is continuous function. Suppose we have a function f of x, and for this function we are plotting it, okay? And always make sure that we are plotting this function within a domain, okay? Let's suppose x defined between 1 and 2, okay? Let's suppose this x is defined between 1 and 2. Now we are plotting this f of x. So this is a plot, let's suppose. Okay, so starting from 1 and ending with 2. So now you can observe that in this domain, the function, okay, so the plot is unbroken. What do you mean by unbroken? See the example. So between 1 and 2, if I'm plotting it, let's suppose this graph going till this point and then starting from this point. So here this is a hole, actually this is jump. So this is not the example of continuous function. So this will be the example of continuous function. Okay, so for an example, so this is not a mathematical definition. This is a simple way to explain what is continuous function. So a function is continuous when graph is single unbroken curve. Okay, this is not a formal definition, huh? This is just a way to explain you the idea for an example. So this is a kind of continuous function. Okay, now let's move into the topic. So what do you mean by continuous function? Okay, so basically, see, this is example. So this is not a continuous. So the graph you can see. So here, like this is a graph and this is going like this. So there is a hole. So basically there is a hole. So this is not a continuous. Okay. And if there is a jump, for an example, if I'm plotting my graph and then my graph starting like this. So this is not example of continuous function. Okay. And something called this one. This is also like one plot is going like this, other plot is going like this. So this is again not example of continuous function. So now you understood what is not continuous. This is example of not continuous. Now we can see more example. See, if I will click on sin x, so now what do you think, sin x is continuous or not? Okay, so make sure that whenever we want to tell that a function is continuous or not, we need to define domain also. Okay, okay, so if I will ask that sin x is continuous or not between 0 to 2, okay, so you can define it. So this is a example of continuous function. So if you take x square, this is again a example of continuous function. What if I will take this 1 divided by x minus 1? This is not an example of continuous. You can see we have two different plot. Okay, if you take this one, this is again not example of continuous function. Why? Because see here, this is not defined at this point. Okay, this is not defined at 1. There is a hole actually. So this is not example of continuous function. Okay, similarly you can take this example. So this is again not example of continuous function because there is jump at x equal to 1.5. Okay, so this is the idea. Basically, if you want to understand in like in a simple term, continuous function is that where if you are plotting it, there will be no jump. Okay, there will be a single unbroken curve. Okay, and now let's move into the topic again. Okay, so I was explaining that domain. Okay, you know about domain and range from the first video where we are discussing what is domain and what is range. Let's say we have a let's say we have a function. Okay, so what is the function? Let's suppose f of x equal to 1 divided by x minus 1. So this function is not defined at x equal to 1. Okay, so this is not an example of continuous. So that means what? There is a discontinuity at x equal to 1. Are you getting my point? So you can take any real number. Okay, so if you're defining the domain of this function to any real number, let's suppose this x belong to the any real number. Okay, so if you're taking that this one, so this will be the discontinuous function. So how you can make it continuous? So if I will ignore x equal to 1, might be it will be the there will be no hole actually. So what do you mean by this thing? Let's suppose, so instead of taking 1, what I'm taking, I'm just changing the domain. So instead of taking 1, what I'm doing, I'm taking the value of x greater than 1. So in this case, this is going to be the continuous function. Understand the difference. So at the start of videos, I was saying that if there is any function and if you want to tell that it is continuous or not, you can tell only if there is a domain. You have to define the domain. So function will be continuous or discontinuous in that particular domain. So in this case, x minus 1, if I'm saying that x belong to the R, so this is going to be my discontinuous function. But if I will restrict my x, okay, if I'm saying that x will be strictly greater than 1, then in this case you can see this is an unbreakable curve. Okay, so we can say this is a continuous now. So hope the point, like the concept of continuous function is clearing. Okay, so we will come to the formal definition in a while. Okay, so we can define continuous using limit concept. How? Basically what we're doing, so I will explain this definition in my term. So uh, you can think like this is number line and this is a point. Let's suppose x equal to c, and there is a function called f of x. Okay, and now let's suppose we have y also. So basically what we're doing, if our function is defined at this point, that is c point, then let's suppose that means what, we are putting value of x as a c in the function, we are getting some answer. Let's suppose we are getting answer a. Suppose we are getting answer a, and then what we are doing, we are finding the left hand limit x approach c minus f of x. Let's suppose when we are finding the left limit of this function, we are getting answer a. Okay, are you getting my point? Okay, so let me change the color. From the left hand side also you are getting a, and then you are finding the right hand limit. Okay, and when you are finding the left right hand limit, you again encounter the answer a. So what you can see, that what you can say here, at like function is defined at point c and you are getting answer a. Okay, when you are finding the limit of function from left hand side, you are again getting a, and similarly from that one. So basically what you are doing, so function is like the limit of function is defined, as well as the function is defined at particular point. So in this case what you can say, that if both are equivalent, we can say that the function is continuous. Okay, in other word, what we can say, that basically limit what say, actually we know from the last video, as x get closer and closer to c, then f of x get closer and closer to f of c. So that we already learned in the last videos. Okay, see, this is a example, right? I think this graph will make picture clear. See, so at this point, so if x is approaching towards c, okay, so f of x will approach to the f of c. Okay, similarly from the right hand side also, when c when x will approach towards c, our f of x will approach to the f of c. So if this is not clearing, don't worry, I will take an example and then this will be easy for you. For an example, let's suppose there is a function f of x. Okay, this is a function. Let's suppose f of x equal to x square minus 1 divided by x minus 1. So if I will say that if x belong to the real number, so in that case this function is going to be the discontinuous, because this is not defined at point x equal to 1. Okay, so we need to change the domain. Okay, if we want to make that function continuous. Okay, so what, we just redefine the function, and in this case the function is going to be the continuous. Okay, so let me take the some real world sorry let me take you the some mathematical problem, so that you will better appreciate the concept of limit. Okay, so this is an example. Okay, so let's suppose there is a one problem. So we have a function, so this function is defined like that: if value of x is between 0 to 1 by 2, so this will be the function. If you're putting 1 by 2, we are getting 1, and if you're putting this value, we are getting this one actually. So basically we need to discuss that is this function continuous or not. So in programming, what you can understand, so there are multiple if else conditions. So if x is between this one, then this will be written, and if x is exactly 1 by 2, you will get this one, and this will be this one. So basically uh, uh, to discuss, like to examine that if function is continuous or not, we need to define like this. So if we are putting directly 1, we are getting 1 by 2. Okay, I'm really sorry, this is not 1 by 2. Let me change it. This is a 1. So when we are putting x equal to 1 by 2, okay, so we are getting 1. And now let's find the left hand limit. So basically we are discussing continuity at point x by 2. So left hand limit at x equal to 1 by 2 will define like this: limit x approach 1 by 2 minus. So left hand limit, that means what? X is less than 1 by 2. Okay, so this is defined at what position? So if you're writing Python code, okay, so there will be multiple if else condition. So if x less than 1 by 2, if I'm saying that, so it will hit this block. So this will be 1 by 2 minus x. Okay, so if you put yeah, 1 by 2 in this equation, what you will get? Okay, if you put 1 by 2, so this will be, this is not 1 by 0 format, make sure we are putting it. Okay, this is a simple limit, but we call it. So we are getting 0. So let's say this is equation, the equation 1, and this is equation 2. So we find the limit at like from left hand side. Similarly, we'll find the limit from right hand limit at x equal to 1 by 2. So limit x approach 1 by 2. So for right hand, that means what? X will be greater than, if I'm saying right, that means what? X will be greater than 1 by 2. Okay, it is going till 1. So this will be 3 by 2 minus x. So if you solve it, you will end with, like if you put the value of x 1 by 2, you will get 1 actually. So if you compare equation 1 and 2, so 1, 2 and 3. So like 1 is not, like they are not equivalent. Okay, so 2 is like equation 2, you are getting 0, which is not equivalent to the 1. Similarly, question 3, you are getting 1. Okay, that is not equivalent to the question 2. So this function is not an example of continuous. So by plotting, you can understand like this. So there is a point 1 by 2. Okay, so the domain is starting from 0 to 1. Okay, so if something is greater than that, so at this point you are getting f. If you are putting f 1 by 2, you are getting 1 basically. But if you're taking limit from the right hand side, you are getting again 1. But if you're taking limit from the left hand side, you are getting 0. So here, so basically if you're taking if you're plotting it, so let's suppose this is going like this. Okay, so this is not an example of continuous function. So if some function is continuous, so the value at that point from left hand side and from the right hand side, all value will be same. So now we will take an example of continuous function also. Okay, so now we have a other function. Here we need to discuss that is this function continuous or not at point x equal to 0. So we have this function. So this mod can be written as like there will be two things. So there will be the answer of this mod will be like 1 plus, other will be minus. So if x is greater than 0, you will get x as a positive. If x is less than 0, you'll get as a negative. So we just redefine the function. Now we have function f of x. If x is greater or equal to the 0, then you will encounter with x. Okay, so basically we are writing if else condition in Python. If x is greater than 0, so you are returning, you are just return x. Else you are returning 3x. Okay, so now we need to discuss the continuity of this function. So what we're doing actually, so if we find out the left hand limit at x equal to 0, so limit x approach to 0 f of x. So if I'm talking about left hand limit, that means what? Left hand limit is as means what? X less than 0. Okay, so we are taking the value from this side. Okay, so where it is defined, this is defined this point, so it will enter into 3x. So limit x approach 0, so here you will get 3x. And now if you put the value of x exactly 0, so you will get 0. Are you getting my point? So this will be equation 1. Similarly, if you find out the right hand limit, okay, right hand limit at x equal to 0, so limit x approach 0, f of x. That means what? X value should be greater than 0. So where it is defined, this is defined here. So limit x approach 0 x, and then if you put the value of x, you will get 0. Equation number 2. And exactly at x equal to 0, what will be the value? So like if x is exactly 0, okay, here in this case limit is what? This is not exactly 0, huh? When it is approaching towards 0, okay, from left and right. So what you are getting? You are getting 0. Okay, now if you're putting x exactly 0, what answer you will get? So in this case, what you're doing actually, uh, mm, so again you're saying that if you put x directly 0 in the function, so this is 0. So if you compare equation 1, 2 and 3, so all our value are same. So we can say that the given function is a example of continuous at point x equal to 0. So this function is continuous at point 1. Okay, so now so whenever we like someone is giving like say that someone is saying that please discuss that if function is continuous or not. So very first thing we need to understand what is domain of that function. Okay, and then based on that we need to find out the left hand limit, right hand limit, and then we need to find out the what will be the what will be the value of function at that point. Okay, for that point we need to discuss the continuity of the function. So in this video, I think you understood what is how to find out the continuity of a given function. So in upcoming videos, we are going to implement continuity in Python programming. So hope you enjoyed it. Okay, so let me discuss some more concept. Okay, so I think I will share this resource with you so you can understand. So here is another example of discontinuity. Okay, so if you have this function, okay, so now if just find it left hand and right hand limit, you will get different answer. Okay, okay. So if I will say that, let's suppose that let's discuss this continuity of this function. So if you find out the left hand limit, okay, so from left you will get 2, from right you will get 1, and at that exactly point you will get 2. So left and right limit is not same actually. Okay, so in this case we can say that this function is not continuous. Okay, so that same thing is written here. So from left we are getting 2, from right we are getting 1. So even limit does not exist at equal to 1. That means there is a jump. Okay, so this is not example of continuous function. I think this is a great resource to learn. Okay, so if you're planning to learn calculus, okay, you want to understand theoretical and you have very short time. So I think math is fun is a great website to learn all this thing. Okay, see, now we have another example. So this is an example. Is this continuous or not? So at x equal to 0, it it has very pointly change. Okay, but it is still defined at x equal to 0. So if you put x equal to 0 in this equation, so exactly x equal to 0, this will be written. So you will get 0. So from left hand side and from right hand side, you will get something. So it is a continuous function, but this is not a differentiable at x equal to 0. We'll discuss why it is not differentiable in differentiation topic. Okay, so I think it is enough.